Hello, can you hear me?
Yeah.
You need to up your volume a little bit. Check the
One
connection.
second, I'll just wait.
Yeah,
Hello, is it better?
yeah, it is better than before. Yeah. Okay, so today we are going to discuss questions from the book Test of Mathematics. Okay.
Yeah.
Did you try any questions here?
Yeah, I started. I
Okay.
tried till, give me a second.
Hmm.
I tried till like 45, 35,
Okay.
235, I mean.
235 is the starting point.
Yeah, so 235 to 245.
Okay, fine. So, 235, did you get the answer for this one?
I did.
So tell me, the question is saying, suppose a plus b plus c and a minus b plus c are positive, and they have said c is less than 0. Then they are asking us whether the equation ax square plus bx plus c is equal to 0 has, where are the roots lying there, right?
Yeah.
So tell me your logic.
So, yeah, so first, like for the first option, I just put 1
Hmm.
as like
Hmm.
x and minus 1 as f.
Hmm.
And both of them are like,
Positive.
yeah.
So basically we
And
have figured out that f of 1 and f of minus 1 are both positive.
yeah, and we will see like only one with the like equal to 0. Sorry,
So
less than 0.
you will get C if you put f of 0, right?
Yeah,
F of 0 is equal to C, and they have given us that f of 0 is less than 0, right? Correct.
yeah. So it's B, right? Like already got the answer.
So how do you already know the answer now? Tell me.
It's like both roots lie between minus 1 and 1, and C is less than 0.
No, but you have to explain the reason. No, you can't just say the answer. Why is it both the roots lie between minus 1 and 1? How do you know that?
Um,
So far, all that we know is that f of 1 is positive, f of minus 1 is positive, and f of 0 is negative.
yeah,
Now, from there to the answer B, you have to explain the logic behind it. It's simple only if you think about the graph of the function. Think of the graph.
uh, right.
See, if you're saying the answer is B, you can't force yourself to say the answer is B. No, you need a reason for it, right?
Right.
So far it seems like you're just accepting the answer as B. You're not explaining a good reason for it. There is a nice reason. But it will only be obvious if you try to draw the graph of the function. Where will I put if the y-axis is like this and this is the x-axis? Where should I mark f of -1? Will it be positive or negative?
Negative.
F of -1 is negative.
Minus one, no. No, wait, it's greater than 0, so it's positive.
So how should I draw the graph of this quadratic? F of -1 will be the value of y. So is it above the x-axis or below?
Above.
So there will be some point somewhere, I don't know where, but it will be somewhere here above, right?
Yeah.
What about f of 0? Where should I mark 0's value?
Uh, Below x-axis.
This is the point where y is f of -1. This is the point where f of 0 is the y value here. And for f of 1 also it is positive, right?
Yeah. So it's again above.
So is the graph looking something like this?
Yeah.
So the graph is positive here, but negative here. So is it crossing the x-axis at 2 points?
No.
If you draw a graph like this, where f of -1 was positive, f of 1 was positive, and f of 0 is negative, isn't it crossing the x-axis at least once here and once here?
Yeah, but it,
Yeah, there is no but, it is yeah only, right? It is crossing the
yeah.
x-axis here and here, no? See, it is very simple. The
Yeah.
function it was positive here, became negative at 0. How did that happen? Will it cross the x-axis or it will somehow jump to negative? The graph
It,
must cut the x-axis, no, somewhere here.
yeah.
So that will be the root because here the value of y will be whatever this point is, it is between -1 and 0, right? At
Yeah.
that point, the value of the function is it 0?
Yeah.
Similarly, again, it will cross the x-axis to become positive at 1. So it must have crossed the x-axis somewhere here where the value of the function has become 0, right?
Yes.
So those are the roots. Roots are the points. By now you should know that roots are the points where the graph cuts the x-axis.
Yeah.
So if this function is changing its sign from positive to negative, quadratic function f of x is going from positive to negative. Between those two values, somewhere it has to become 0, right?
Yeah.
So there is a root between -1 and 0, and there is another root between 0 and 1 somewhere. We don't know where, but it has to happen. Correct?
Yeah.
Do you understand why the answer is B now?
Yeah.
There are a couple of roots alpha and beta, both of them between -1 and 1. The reason is that the value of the graph was changing from positive to negative, and therefore it cuts the x-axis in the middle between -1 and 0. Similarly, between 0 and 1, from negative to positive, right? Are you understanding what I'm saying?
Yeah, understood.
This is an example of a famous property. It is called Descartes' rule of signs. So what he said was, if f of x is a polynomial equation, like f of x is equal to 0 is a polynomial equation. Why am I saying polynomial equation? Because it doesn't have to be a quadratic. It could be a cubic or a fourth degree equation also, right? Between any two, like what we can say is between any two changes of signs in the value of f of x, there is always a root. I'm not saying it perfectly, but what I mean is whenever f of x changes its sign from positive to negative to positive, you can check different values of the function at x is equal to 2, 3, 4, whatever, right?
Yeah,
If it is changing its sign from while it goes from 2 to 3, then there is a root between 2 and 3, obviously, because the graph has to go from positive to negative, so it will cut the x-axis, right?
yeah,
Similarly, if it is changing its sign from negative to positive, there will be a root between them. If after that it is not changing its sign, then there are no further roots. But whenever there is a change of sign in the value of a polynomial, then there will be a root between those two endpoints, wherever the sign change is happening. Is it clear?
yeah.
Okay. Then we'll look at 236 then. The question is asking number of real roots of the equation. Notice that this is a cubic equation they have given you. Number of real
Yeah,
roots lying between -1 and 1, right?
yeah,
So basically it's a cubic equation, and between minus and on 1 and 1, we have to find how many real roots are there, right?
yeah.
So, okay. So let's find out first of all what is f of -1, right?
-1 is 3. Sorry, -1.
-8 plus 6 plus 1. So it is -1.
-1.
And
Yeah,
similarly, f of 1 is 8
is
minus
3.
6 plus 1. It is
3.
plus 3, right?
Yeah,
So first of all, it is guaranteed that the sign has changed, right? Correct?
yeah,
So at least one root lies between -1 and 1, right?
yeah,
Because the graph of the function is negative here and then positive here at -1 and 1, right? So at least one root definitely lies between -1 and 1, right?
yeah.
Now you should know there is something called the fundamental theorem of algebra. Fundamental theorem of algebra. What that says is any n degree equation has n roots. Any n degree equation has n roots. The roots may be real or complex, may be real or complex numbers. Okay.
Okay.
You have not studied complex numbers so far, right?
No.
So we will discuss it later. So for example, in a quadratic equation, imagine if the discriminant was less than 0, what do we say? We say that there are no real roots, right?
Yeah.
So when there are no real roots, actually here we will say that there are two complex roots. Later you will learn about it. When there are no real roots, there will be two complex roots because by fundamental theorem of algebra, a quadratic equation has degree 2, right?
Yeah.
So it has to have two roots. Real roots could be 0 or 2. Complex roots will be 2 or 0. Do
As
you
in?
understand?
No.
Obviously, the total number of roots have to be 2, no?
Yeah.
If the real roots are 2, complex roots will be 0. Correct?
Okay.
If
Yeah.
the real roots are 0, then there are two complex roots, right?
Right.
Basically, that is the idea that total number of roots have to be n if the degree of the equation is n, right? Do you understand what I'm saying?
Yeah.
So quadratic equation, we have not studied complex numbers yet, so we cannot actually tell you what exactly those roots are, but we will do it later. For now, just remember that if it's a cubic equation, total number of roots have to be 3, right? Correct.
Yeah.
Total roots have to be 3.
3.
Now, it could be 1 real, 2 complex, or it could be 3 real and 0 complex. Okay.
Okay.
There is another idea here that complex roots always come in pairs. So complex roots, whenever they will appear, right, they will always come in pairs of 2. So it will either be 2 or 0 or 4 or 6, things like that. It will never be one complex root. Odd number complex roots will not be there. Okay. So in this problem, right now we know that there is one real root between -1 and 1, but we have to confirm whether it is 1 or 3. Because it could be 3 real also, no?
Yeah.
For example, look at the graph of a cubic. Graph of a cubic could be drawn like this. Now, it depends whether a -1 and 1 are like this or whether a -1 and 1 are like this, right?
Okay. Yeah.
This is a cubic which has 3 roots. There are also cubics which are like this. Notice that it doesn't cut the x-axis again. So only one root for this cubic, right?
Yeah.
So there are two types of cubics. Two types of cubics. One type is when it has 3 roots. These are the 3 roots, right? And
Yeah.
one type is when it has only one root. This is a typical graph of a cubic which has only one root, right?
Right.
In our question, we have to figure out whether between -1 and 1, how many roots are there for our particular cubic, right? We know f of -1 was negative and f of 1 was positive, right? Correct.
Yeah.
So it could be two cases. Here it could be two cases, or here it could be like this, right? It could be like this, situation could be like this, or situation could be like this, or +1 could be instead here, right?
Yeah.
So basically the answer could be there could be 3 roots or there could be one root.
Yeah.
Do you understand what I'm saying?
Okay, yes.
Either three roots can be there between, because the curve can come down again and again go up, intersecting three times between -1 and 1, right? Or it can intersect only once between -1 and 1, or it could be a curve like this, right? I hope you're getting what I'm saying.
Yeah.
Now, how to decide that? So f of x is 8x cube minus 6x plus 1. Notice that at 0, the value is already positive, right? At 0, the value is positive, right? So
Yeah.
technically, the function has become positive already before +1. At 0 only it is positive, right?
Yeah.
So the root is actually lying between -1 and 0, right?
Right.
Correct, no?
Yeah.
And one easy way to figure out the sign of the function, or figure out how the function is increasing or decreasing, is by calculus, where you can differentiate this function. But I don't think you know calculus right now, right?
Mm.
So right now we cannot do further than this, because we are not able to factorize this. So we cannot really figure out whether it is 3 or 1, because this will involve doing a little bit of calculus. Okay. This question involves calculus, because if we figure out the derivative, then we'll be able to predict what happens to the original function. Okay. So
Yeah. The next question is also pretty similar. Like, it also, I think, involves derivatives.
let me just see. So question 236, you should mark that we'll do it later because it involves calculus. Okay.
Okay.
So let's look at but this much is obvious, that the answer can only be between B and D, right?
Yeah.
Okay. 237, if we look at, it is x cube plus 7 divided by x square plus 1 equals to 5. And we have to check for solutions between 0 to 2, right? In this range, right? How
Yeah.
many solutions are there between 0 to 2? So, okay, let's think about it. First of all, I will simplify this equation. X cube plus 7 is equal
Becomes
to,
x cube minus 5x plus 2.
hmm, so it becomes this, right?
Yeah. Plus 2,
Okay.
sorry.
So,
And like I put in 0 as like x and
hmm,
then 2. And
hmm.
1, the 0 one is 2 and the 2 one is minus 10.
So this is -20 plus 2, so -10, right? So
Yeah.
again, we know that there are roots between 0 and 2, right?
Yeah.
But it could be 1 or 3 again, right?
Yeah. Right.
And the only way to figure out how to get how many roots is by taking derivatives again. Unless if you can figure out a factorization, if you can spot a root. Let me just think for a moment. 3 cube, 5, no. It is not obvious. There is roots between 0 and 2, but we don't know how to guess it, right?
Right.
If we were able to guess a root, no, then we could have factorized this. Then it would be easy. Like, one
Guess a
second.
root as in?
Guess as in, like, can you guess a value between 0 and 2 which makes the whole thing 0, right? The root location. We know that there is a root between 0 to 2, right?
Yeah.
Right now we don't know which number is the root. So 1 doesn't fit. 1 is not a root, right? Notice that 1 makes it still negative, right? Oh, 1 is making it negative, right? So the root is between 0 and 1. Do you understand?
Okay.
Because f of 0 was positive, f of 1 is negative, right? correct?
Right.
So the
Yeah.
root is between 0 and 1, but we don't know whether there is one root there or three roots there, right?
Right.
The way to figure it out would be take f dash x, which is 3x square minus 10x, and figure out where it is getting maxima and minima. So we can say that that will happen at x is equal to 0 and x is equal to 10 by 3. So 10 by 3 is the point of maximum minima. And double derivative is 6x minus 10. At 10 by 3, it is 6 into 10 by, it is positive, so it is a minima. X is equal to 10 by 3 is a point of minima. But 10 by 3 is anyway beyond. Oh, okay, okay. The answer it has only one real root. The reason, how am I saying it so easily? Because when I take derivative and I get this, between 0 to 2, the derivative, notice, is always positive or is always negative. If you take 3x minus 10 into x, right? Between 0 to 2, it is negative, no, throughout.
Yeah.
One of them is positive, one of them is negative. The product is negative, right?
Yes.
So because the derivative is coming as negative in this region, the graph is always, the function is always going down. It is decreasing function. Okay. So right now I'm not going to go into details and you are not expected to solve this right now. But what I'm telling you is if you knew that the function was decreasing from 0 to 2, right?
Yeah.
Then can it have more than one root? Do you understand? It is not possible, no? If the graph of the function was always decreasing from 0 to 2, it will
Then
only
it
cut the
can't.
x-axis once, no?
Once only. Yeah.
But if the graph of the function was more complicated, like decreasing, increasing, decreasing, then there are three roots, right?
Yeah.
So basically, the only point where you need calculus is to figure out whether the graph is decreasing or decreasing and increasing or more complicated behavior, right?
Right.
So what calculus has told me, it doesn't matter that you don't get it right now. What the derivative tells me is that the function f of x is decreasing completely in the interval 0 to 2. F of 0 was positive, f of 2 is negative, and it is constantly decreasing. And that means it can only cut the axis how many times? Once, right?
Yeah.
Do you understand what I'm saying?
Yeah.
That is what you have to do for the previous one also. Figure out whether the graph is increasing or is it increasing and decreasing. Do you understand?
Okay.
So when we study calculus, we will know exactly, but here the answer will be C, exactly one solution. Okay?
Yeah.
Okay, fine. We'll go to 238. Don't worry about these things. We'll anyway study calculus soon. So it will all be covered eventually. So 238 is roots of this equation you have to find, right?
Yeah.
Were you able to find it?
No.
Okay, so
I
what happened?
My first thought was like, let's make y equals to like root
Hmm.
of x square,
Hmm.
and
Wait.
then
Let's make what? First
like
thought was what? Tell me.
or like y equals to root x square minus 3x minus 6, that way.
That's the
Something.
correct thought. But you have not followed through on your first thought. That's why you're not getting.
So like
After that, you have given up. That's your problem. If you put y is equal to 3x square minus 3x minus 6, it will immediately solve the problem. All you have to do is simplify it a little bit or rearrange the equation. Look at it, how it will happen. 2x square minus 6x minus 10 is equal to 5 times root over x square minus 3x minus 6.
So it's x square minus 3x minus 6 equals to 5y.
No, 5 root y.
Oh, okay.
Can you see that I have called this as y? You said this is y, right?
No, I thought the entire root was y.
That doesn't make a difference. The
Yeah.
substitution value doesn't make a difference. If you had just rearranged all the terms like this, brought the other things here and the root on one side, then if you take this, you will get 5 root y is equal to 2y. Can you see that?
Oh, yeah.
You can take 2 common here and you're getting the same thing again on the other side.
Yeah.
So the question is so easy here because now we can say y can be 0 or root y we will cancel and root y will be here. So root y is 5 by 2. So y will be 25 by 4, right?
Yeah.
So you're getting two different things. Pi can be 0 or 25 by 4. The question is not over because now you have to solve for x finally, right?
Yeah.
But you will do two cases. X square minus 3x minus 6 is 0. And also x square minus 3x minus 6 is equal to 25 by 4.
By 4. Yes.
But these are straightforward quadratics. You can solve by the formula.
Right.
So your idea was correct, but then you didn't do it, no, fully. Idea
Yeah,
was
I got
correct.
stuck.
You have to rearrange the terms and notice that taking this as y immediately converts the other thing also in terms of y to y, right?
Right.
Okay, so you can finish the problem now later. Let's move on to 239. The question says, suppose that the roots of ax square plus b lambda x plus lambda equal to 0, where a and b are real numbers and they are given, so they're constants basically.
Yeah.
A and b are real numbers. The roots of this equation, question is saying, are real, are real for all positive values of lambda. Correct?
Yeah.
Then their question is asking us to find an inequality or look at the options and figure out what is correct, right?
Right.
So if somebody says the roots of a quadratic are real, what is the inequality that comes to mind first thing?
Greater than 0.
What is
Greater
greater
than or
than
equal to
what
0.
is greater than equal to 0?
The discriminant.
So discriminant is greater than equal to 0 is the first thing. And for this quadratic, what will be the discriminant?
Uh, B, what sign is that?
Lambda.
Okay. Lambda, right. B lambda whole square minus 4a lambda.
Right. So
So we
this
can
is the
also write
inequality.
as, okay, yeah,
This is what we are getting should be greater than equal to 0, right?
right.
So b square lambda square minus 4a lambda is greater than equal to 0. We can take lambda common. We get b square
Yeah,
lambda minus 4a is greater than
yes,
equal to 0, right?
right.
Now the question has said that the roots are real for all positive values of lambda. So you are only allowed positive values of lambda, right?
So more than 0.
So this value lambda is positive, we already know, right?
Right.
So we can remove that inequality, right? We can remove that from the inequality, I'm saying, because we already know the sign of this, right?
Yeah.
So we can say for sure that this quantity must also be positive, right?
Right.
Then only the overall thing will be greater than 0, right?
Yeah.
So we can say b square lambda minus 4a must be greater than 0, right?
Yeah. And B
Correct,
is
no?
also not 0. Because, like,
Ah,
no.
no, b we don't know anything about. We know that they are real numbers, right? So right now we know that b square lambda is greater than equal to 4a, right? Correct?
Yeah.
And we know that
No,
this,
but B can't be 0.
why?
Because if like B is 0, then it becomes minus 4A is greater than 0.
That's possible if a is negative.
Oh, my bad.
We are getting a situation like this. And here we can say that b square is greater than equal to 0 because it's a square. And lambda is also greater than 0, right? So this quantity is completely positive, right?
Right.
Okay. Okay, that doesn't help us much. 1 second. Suppose the roots of this equation are real for all positive values of lambda. Roots are real for all positive values of lambda. So basically, this inequality should be always true, right?
Does it?
For any value of lambda, this inequality has to be true, no? Must be true for any positive value of lambda. That's what the question is saying. Correct?
Yeah.
Question is saying it's not just true for one or two values of lambda, for any positive value of lambda. Correct?
Right.
So even if I take a very small positive value of lambda, like lambda is almost like positive, but 0.00000000001, right? Even then it
Right.
has to be true, right?
Right.
Because the roots are still real, right? That's what the question is saying, right?
Yeah.
So regardless of the value of lambda, we need to make sure that this is correct. So we can say from here, what are we getting? We are getting 4a is less than equal to b square lambda, right? So
Right.
4a by b square is always less than equal to lambda, right?
Right.
Correct, no?
Yeah.
Now notice that lambda can be positive, but it can be a very small positive also, right?
Right.
So one way to ensure that regardless of the value of this, the inequality is always true would be if a is less than equal to 0, the left side is negative and this is positive, right?
Right.
How can we make sure that the inequality is always true for any positive value of lambda? Think about it. The only way to make sure of that is that if the left side is negative, right?
Negative. Yes.
Because any positive will be bigger than negative, right?
Yeah.
We can make left side negative only by changing the sign of a because b square is always positive, right?
Yeah.
We have to say a should be less than equal to 0. Then only we can say for sure, no?
Right.
See, suppose I don't take a as negative, right? Suppose I don't take a as negative. Now, if I pick a small value of lambda, how can I guarantee that 4a by b square will always be less than that? Can I guarantee it? No, no, no.
No.
Because for A and B cannot be changed. A and B are fixed, right?
Yeah.
So 4a by b square will be a fixed value. How it will not be true for any random value of lambda. No, it might be true for some values of lambda, right?
Right.
But if a was negative, if a is negative, then left side is negative, and the left side is always smaller than a positive thing, right?
Positive. Yes.
Then it will be true for all positive values of lambda.
Right.
Do you understand the logic?
I do.
So the question starts with the discriminant. Then you should realize that because lambda is positive, I only need to ensure that this part is positive, right? Correct?
Right.
And here, how to figure that out? Now you have to think that I know that lambda can be any positive value, but it could be a small value, right? Correct? Since
Right.
a and b are known, 4a by b square must be smaller than equal to lambda, but then we don't know which lambda to take. So only way to make that happen all the time is to make 4a by b square negative, right?
Right.
So that's why the answer will be a should be less than equal to 0. Do you understand?
Yeah.
Okay, fine. We'll go to 240. In 240, we have two equations. X square plus x plus a equals 0. And another equation is x square plus ax plus 1. Okay. And we have to figure out whether they can have a common real root. And for how many values of a and all, right?
Yeah.
So this is an important idea. Two quadratic equations, when can they have a common root? Having a common root. Do you understand the question, the meaning?
Common root as in like both.
Same root. Like this
Yeah.
quadratic could have root alpha beta, and this quadratic could have
This one also
alpha
have
gamma.
roots.
So then we can say that alpha is a common root, right?
Right.
So that is the condition that has to be understood. Like you have to understand how to figure out whether two quadratics have a common root, right? Do
Right.
you understand the problem?
Yeah.
Okay. So for this, we will do this theory that is important to know. So let's say our quadratics are like this. A1x square plus b1x plus c1 equals 0. And another quadratic is a2x square plus b2x plus c2 is equal to 0, right?
Yeah.
Right now we are doing the derivation of how to get the condition for common roots, okay? So alpha and beta are the roots of this, and alpha and gamma are the roots of this. So we are saying alpha is a common root, correct?
Right.
I need to figure out a condition so that this happens, okay?
Okay.
So, since alpha is a common root for both the equations, can I write a1 alpha squared plus b1 alpha plus c1 is 0? I can also write a2 alpha squared plus b2 alpha plus c2 is 0, right?
Right.
Basically, if you put alpha, the two equations should be true, right? Satisfied. Do
Right.
you understand so far? So,
Yeah.
how to get the condition? What we will do is there are two steps to it. Solve for alpha as a variable. And second step is solve for alpha square as a variable. So what I mean by that, I will explain. So here there are two equations. Think of alpha as a variable. I want to solve for alpha or get alpha is equal to what? Okay. So remember always that A1, B1, C1, A2, B2, C2 are constants, right? Coefficients, right? Do you understand what I'm saying?
Yeah.
So the only unknowns in this equation are alpha and alpha squared, right? So think of it as a simultaneous equation and I want to solve for alpha first, okay? So in order to do that, I should eliminate the other variable alpha square, right? Do you understand what
Okay,
I'm saying?
yes.
You should
Yes.
remove the other variable, no, somehow, right? So how to do that? I will multiply the first equation by A2 and the second equation by A1 and I will subtract. So notice what will
Okay.
happen. A1, A2 alpha square, A2 B1 alpha plus A2 C1 is 0. And here I have multiplied by A1 to match this term. So A1 A2 alpha square comes again. And I'm getting A1 B2 alpha plus A1 C2 is 0, right?
Right.
If I subtract, automatically this term gets cancelled, right?
Yeah.
And you will get A2 B1 minus A1 B2 alpha plus A2 C1 minus A1 C2 is 0, correct?
Right.
So from here we can solve for alpha, no? Alpha is equal to A1 C2 minus A2 C1 divided by A2 B1 minus A1 B2, right? Correct?
Right.
Remember A1 B1 C1 A2 B2 C2 are all numbers. So this is the value of alpha, right?
Yeah.
So we have solved for alpha. That was the first step. Now, similarly, you should solve for alpha square. And to do that, very similar process. If I want to solve for alpha square, I should eliminate alpha, right?
Right.
In order to eliminate alpha, I need to make the middle terms match, right? Correct?
Okay, yeah.
So I will multiply the first equation by obviously B2 and second equation by B1, right? And then I will subtract, no?
Yeah.
Do you understand that that will cancel the middle term?
Right.
Is it completely clear or there is some doubt here?
No, got it.
So you will get A1 B2 minus A2 B1 alpha square plus C1 B2 minus C2 B1 is 0 after cancelling the middle term. And you will get a solution for alpha square now, right?
Yeah.
So this is what we are getting. Alpha square is equal to this. Correct?
Okay.
So what have we done? First step we solved for alpha. Second step we solved for alpha square. But because alpha and alpha square are obviously related, can't we say that this thing is equal to this thing square?
Right.
Do you understand what I'm doing? I'm saying that from here alpha is this and from here alpha square is this. So we can equate this thing to square of this, right?
Okay, yeah.
So notice that this will be your condition and that condition only involves the coefficients, right? Nothing else is involved in this condition, right? Correct.
Yeah.
So just depending on the coefficients of the two quadratics, I can get a condition to see whether alpha is a common root, right?
Right.
You have to understand the process by which we come to the condition. Don't try to remember this. Nobody can remember this, okay? You don't have to remember the condition's actual statement. You have to understand how we do it.
Okay, yeah.
We say that alpha is a common root. We make two equations involving alpha, right? After that, from those
Yeah.
equations, we'll solve for alpha and we'll solve for alpha square. And at the end, we'll equate them, right?
Yeah.
Do you follow the overall process?
Yeah.
That final thing, whatever comes, is your condition for common root to happen, right?
Okay.
So now what we will do is we'll apply this theory to this problem, okay? So our equations are now x square plus x plus a is 0. And the second equation is x square plus ax plus 1 is 0, right?
Yeah.
And many of the options are asking us whether they have a common real root and all, right?
Yeah.
So let's assume they have a common real root. Let's say alpha is a common root, right?
Right.
So in that case, we should be able to put alpha in both the equations and get two equations. Alpha square plus alpha plus a is 0. And second equation is alpha square plus a alpha plus 1 is 0, right?
Right.
And for common root, we will follow our method, right? Our method is simple. Solve for alpha, then solve for alpha square, right?
Yeah.
So in order to solve for alpha, I should eliminate the alpha square variable, right? But that is pretty
Yeah.
easy. We don't even have to multiply. We just have to subtract, right?
Subtract. Yeah.
Simply subtract. So we'll get alpha 1 minus a
Minus.
plus a
Yeah.
minus 1 is equal to 0.
Yeah.
Correct? So we are getting
Yeah.
alpha into 1 minus a is equal to 1 minus a, right?
Yeah.
So notice here, it could be that a is 1, right? If a is 1, both the equations are identical, right?
Yeah.
If a is 1, there will be two common roots, right?
Right.
Actually, both the equations will become x square plus x plus 1, but x square plus x plus 1 has no real roots actually, because the discriminant for this is negative,
Oh.
correct? Can you see? It should have two common roots, but actually both the roots are complex roots. Do you
Right.
understand what I'm saying? So no real common root, right? Because actually if a is 1, the equations are giving us no real roots, right? Do you understand what I'm saying right now?
Yeah.
Why am I checking a is 1? Because if a is 1, this is 0. So then alpha doesn't make any sense. That's why there are no real roots. But in other cases, alpha is coming as 1, right? 1 minus a by 1 minus a, right?
Yeah.
So we are actually getting the value of alpha, right? Correct?
Right.
What about alpha square? If I solve for alpha square, I will have to eliminate alpha, right? Correct?
Yeah.
See, my first step was solve for alpha. I solved it and I got alpha is equal to 1, right?
Yeah.
Correct? My second step is solve for alpha square, right? So in order to solve for alpha square, I should multiply the first equation by a and leave the second one as it is, right? Because then only I can cancel the middle term, no?
Yeah.
Do you understand? To solve for alpha square, I should eliminate the alpha variable.
Yeah.
So I'm getting alpha square plus a alpha plus a square and subtracting from there alpha square plus a alpha plus 1, right?
Right.
And no, this is a alpha square because I multiplied the first equation by a. So it is a alpha square, right? So you are
Yeah.
getting a minus 1 alpha square this gets cancelled, plus a square minus 1 is 0, right?
-1. Yeah.
So we are getting alpha square into a minus 1 is equal to 1 minus a square, right?
Yeah.
So from here we are getting alpha square is equal to 1 minus a square by a minus 1, right?
Yeah.
But from the previous case, we have already got an alpha is 1, right?
Yeah.
So we can put that in this. At the end, remember, we have to combine both the conditions, right?
Yeah.
So we are combining it by putting alpha is 1. So then the equation becomes a minus 1 is 1 minus a square, right?
Yeah.
So it is becoming a square plus a minus 2 is 0, right?
Okay.
Correct?
Yeah.
And so the condition for common root is if a square plus a minus 2 is 0, right?
Yeah.
And a square plus a minus 2 is 0 will happen when a plus 2, a minus 1 are the factors, right?
Right.
So one value of a coming from here is a is minus 2. The other value of a is coming as a is 1, but we have already seen the a is equal to 1 case, right?
Right.
If a is 1, they should have two common roots because both the equations are same, but actually there are no real common roots because there is no real root for this equation, right? Correct?
Right. Yeah.
But if a is minus 2, they have one common root then, right?
Right.
If a is minus 2, that was the other value, no, here that we got for common root.
Yeah. They will have one common.
So minus 2, let's put minus 2 and see. One equation is x square plus x minus 2. The other equation is x square minus 2x plus 1, right?
Right.
Notice that this equation has x minus 1 whole square. So this has roots 1 and 1, right?
Right.
And this equation has x plus 2 x minus 1. So it has roots minus 2 and plus 1, right?
Yeah.
Can you see there are common roots now? 1.
Common root. Yeah.
The main idea, so we'll say that they have a common real root for exactly one value of a, right?
Right.
We will not say two values of a because when the second value we take as 1, we don't get any real root, right?
Right.
So we'll say option B because that is saying have a common real root for exactly one value of a. The value of a is minus 2 and the common root is 1.
Right.
But the main point is not to like worry about the particular question. Understand the general process how we detect common roots.
Got it.
Have you made some notes and all for this because this is important.
Yeah. Yeah. I have notes for all the questions.
Okay, fine. So we figured this one out. Uh, We'll now move to 241. It is given that the expression ax square plus bx plus c takes positive values is greater than 0 basically for all x greater than 5, right? Okay,
Right.
now we have some options. First option is equation ax square plus bx plus c is equal to 0 has equal roots. Second option is a is greater than 0 and b is less than 0. Third option is a is greater than 0 but b may be positive, may or may not be negative, right? May be positive or negative, right? And option D is C is greater than 5. Correct?
Yeah.
So for all x bigger than 5, this quadratic is positive. Okay. So let's analyze the case where a is greater than 0, right? Because two of the options have that, right? Correct?
Yeah.
So if we analyze the case where a is greater than 0, then the graph of the quadratic can be having three types of graphs, right? It's an upward facing parabola. It can be either this or this or this, right?
Right.
Now, when can we say that for all x greater than 5, the quadratic is positive? We have to figure that out. For all x greater than 5, the quadratic is positive. It can happen in any of these two cases, so for sure it can happen, no? Because the quadratic
Can
is.
you give me a minute?
Hmm,
Someone's at the door.
hmm.
Yeah, back.
Hmm. So what we are saying is in these two graphs, right? Here the quadratic is anyway always above 0, right?
Right.
For all x greater than 5. So this graph also, if x is somewhere here or somewhere here, if x is not, if x is 5 here, then it will be 5 is somewhere here, then, but here it will be 0 here somewhere, right? We need to make the quadratic always greater than 0, not equal to 0, right? So basically the root should be smaller than 5. 5 should be here, right? Correct?
Right.
So both of these graphs will work. Both of these graphs will work. Here discriminant is less than 0, so it's always positive anyway, right? Here you should say discriminant is less than 0, no, equal to 0. But also you have to say that 5 cannot be here, right? 5 cannot be this side of the graph, right? Do you understand what I'm saying?
Okay, got it.
If 5 is this side, then for x greater than 5, there is a point where it is 0, right?
Right.
But the question is saying it should always be greater than 0 for x greater than 5, right?
Yeah.
So this is not allowed, right? What should
Right.
happen is if the graph is like this, where equal roots graph is there, where discriminant is 0, then 5 should be on the right side of the root, correct?
Right.
Because then for all x bigger than 5, the graph is always positive.
Yeah.
So in this case, you should say discriminant is 0 and the root 5 is bigger than the vertex of this graph, which will be minus b by 2a, right?
Right.
The root of this graph is always at the vertex, which is value is minus b by 2a, right?
Yeah.
So these two conditions will ensure what we want to happen. Correct?
Yeah.
Now, for the other graph, for this graph, where discriminant is positive, is it possible? It is possible if you say that 5 is here, right? 5 is here. Above 5, it will be positive, right? Correct?
Yeah.
So here also it is possible if discriminant is positive, but you have to make sure that f of 5 is greater than 0, right? The value
Right.
of 5, the graph at 5 is greater than 0. So there are additional conditions in this case also and in this case also, right? There are additional conditions here. This is the only case where we don't have to worry about anything for all x greater than 5. So b square minus 4ac less than 0. When will this happen? When 4ac is bigger than b square. A is bigger than 0, so c should be also positive. Ax square plus bx plus c is greater than 0 for all x greater than 5. Okay, so we are not getting any option looking like this here because nobody is saying anything about C. So let's look at the third case, this case. We are getting D is 0 and this happens. So minus B by 2A is less than 5. And if A was positive, 2A is positive. So we can say minus B is less than 10A, right? So we can say multiply by minus 1 in this inequality, it will reverse its sign. So B is greater than minus 10A. So B should be greater than some negative 10A. But then B can be positive or negative both, right? Do you understand what I'm doing right now? I'm trying to check this condition, okay?
Okay.
This condition is possible, graph where discriminant is 0 and 5 is greater than minus b by 2a. So from here I'm getting minus b by 2a is less than 5, minus b is less than 10a. Because we know a is positive, I can multiply by 2a without changing the sign of the inequality, right?
Right.
So I'm getting minus b is less than 10a. But now I want to get a condition on b, not on minus b. So I'll multiply both sides by negative 1, but that will reverse my inequality, right?
Yeah.
If you multiply any inequality with a negative quantity, the inequality has to be reversed. So I'm getting b is greater than minus 10a, right?
Yeah.
But a is positive, so this quantity is a negative number. So b is greater than some negative number, right? Correct?
Yeah.
B is greater than something negative means b could itself be negative or it could be positive also, no? Right?
Right.
So this option is possible here, right? Because we have seen a greater than 0 and b can be positive or negative, right?
Right.
Do you understand what I'm saying so far?
Yeah.
Also, discriminant is 0. So we should also have b square minus 4ac is equal to 0. So b square should be equal to 4ac, which implies that c has to be positive. Because b square is anyway positive always, right?
Yeah.
If a is positive, c has to be positive. So ac
Yeah.
have to have,
Just.
a and c have to have same sign. If a is negative,
Yeah.
c has to be negative, right?
Yeah.
So right now from the options, I can say that this option seems right. This also is, it's a weird question. The options are not correct because it's confusing because I don't know what they want you to do here. 241. The 241 he has said answer is C, which is what we are also saying, right?
Right.
But the main thing to understand is, eh, see, all the other cases, why are we not doing? We are not doing other cases because they have additional conditions like this, right? Correct? Basically, you have to say something about A, B, C combined, no?
Yeah.
None of the options are saying anything about that. This is the only case where you are only getting a condition on A and B, right?
Yeah.
Do you understand that it is possible in all three cases?
Yeah.
It is possible in all three cases that the graph is bigger. 5 could be here and above 5 it is positive. Here though there is no issue only. The only thing is d is less than 0, right?
Yeah.
And here we have to say 5 should be above and vertex is here minus b by 2. 5 should be ahead of the vertex, right? Correct?
Right.
Then only you'll get positive values for this, no? It is possible in all cases, but here, for example, you'll have to say f of 5 should be greater than 0, which will mean you'll have to put 5 into the equation. You'll get 25a plus 5b plus c is greater than 0. But none of the options are looking like that, right? Correct?
Yeah.
Here also it is possible, but you'll have to again say b square minus 4ac is less than 0. Again, nobody is saying, no, none of the options are saying anything about c and all.
Right.
Or how we'll verify this? It doesn't look like any option is matching. So I'm honing in on this one because here we are getting minus b by 2a is less than 5. And that gave us that b should be greater than minus 10a. Which means if a is positive, b can be negative or positive, which is a correct option. Right?
Yeah.
So it's not like there is a single answer to it. There is more to it here. But according to the options, that's the only reasonable option, I think. Do you understand?
Yeah.
Okay. So 242, the roots of this equation, half x square plus bx plus c equals 0. Roots are integers. If the condition for the roots to be an integer, right? So this is an important theory idea. So think about it. By quadratic formula, the roots will be what? Minus b plus minus root over b square minus 4 into half into c divided by 2 into half, right?
Yeah.
So the roots are minus b plus minus root over b square minus 2c by 1, correct?
Yeah.
So anyway, it will come out as a thing like this. 1 can be removed. The only condition for roots to be integers is first of all, b square minus 2c is greater than equal to 0, right?
Will it make a difference if I like make it into like x square plus 2bx plus 2c equals to 0?
It won't make
Like I
any
just,
difference. Doesn't make any big difference. The same thing will come eventually. Any equation, if you multiply by 2, it doesn't make a difference. No, roots will still be same, right?
right,
So the discriminant should be positive, then only it will be real roots, right?
yeah,
That's the first condition. Second condition is b square minus 2c should be a perfect square, right?
yeah,
If it is not a perfect square, you will be stuck with a square root, correct?
yeah,
So that will make it not an integer, right? Do you understand what I'm saying?
yeah,
So now this should happen, this should also happen, right? Then we have to think about it. So notice that if B and C are even, B and C are even, what happens then? We get, okay, we can't say much here directly. Uh, we are getting B square. One of the options is saying B square minus 2C should be a perfect square. And B is an integer. How do we know that B is an integer? The reason here we can also use Vieta's relations. So what is Vieta's relations? Sum of the roots and product of the roots, right?
right,
Sum of the roots is minus b over a, right? So this will
yeah,
be minus b over half, right? Correct?
right,
So if the roots are integers, shouldn't b also be an integer now? Because the sum of the roots is an integer and it is equal to minus 2b, right?
right,
Do you realize that b has to be an integer?
yeah,
Because sum of the roots is coming as minus 2b and sum of roots has to be integer. So b should also be an integer. And you can even say product of the roots is c over a, c by 1 by 2. That is 2c. And c is also an integer, right?
yeah,
So basically we are getting that for roots to be integers, both b and c have to be integers. Correct?
right,
And b square minus 2c should be a perfect square. Correct?
yeah,
So we will say option B because b square minus 2c being a perfect square is an important condition. Although option C is also technically correct, but it is not sufficient, right?
right,
B and C being integers does not ensure that the square root is not is an integer, right? Notice option C is not sufficient. It is true, but it is not enough. Correct? Are you understanding what I'm saying?
yeah,
So I will say option B is the answer for this.
okay,
Okay, so what you need to do is keep trying. You have to attempt till uh 200. 1 second, let me just see. See, ultimately we have to attempt till 270, you can say. We should attempt till 270. After that, we'll move on to the next chapter. Okay.
yeah,
So we will move on to the next chapter, but maybe a couple more classes are required. It doesn't matter that you're not able to fully solve things right now. What you need to do is take it as a learning exercise. Try the questions, see how much you can do, check the answers, and in the class when we discuss it, you will learn new things. Okay.
Sir, can I like
Hmm.
submit the homework by Monday? Because like my school starts, I'll have schoolwork as well. Like I'll use the weekend to like complete most of the work.
That is not an issue, but we'll do a class on Saturday. You
Yeah, yeah.
you have to keep trying. It's fine. There's no deadline on the homework, but the point is by Wednesday next week we should finish till 270.
Okay.
Okay. So next
Yeah,
week's
got it.
Wednesday's class, I want to like then I will finish quadratic and then we'll move on to the new chapter after that.
Okay.
So we have two more classes for it and just work on it till then. There is no deadline for the homework as such. The deadline is Wednesday. Okay.
Okay.
Okay. That's all for now then. I'll see you next
Thank you.
time. Hmm.
Bye.
Bye.